that really aligns with what we're going to talk about, how we can introduce test prep throughout the whole school year and throughout our instruction. And without further ado, I'm kicking it over to you to introduce yourself.
All right, boom, let's do it. Hi everybody. My name is Emily Miller. My pronouns are she, her. I was a high school chemistry teacher for 10 years. And while I was a teacher, I taught in our alternative learning program, regular chemistry, honors chemistry. So I had the opportunity to teach at various rigorous levels and learn different strategies because of that. When I was a teacher, I considered myself as an NGSS pioneer and advocate in my department, and I was also a PLC lead, so I got to lead a lot of data-driven dialogue amongst my colleagues. And now I have the lovely opportunity to partner with districts to help them implement InnerOrbit and to help them utilize our tool. And it might be controversial, but if I had to pick, I would rather eat savory food than sweet food. Like I would, as much as it pains me to say, like I'd give up like dessert if I could just like have like a good steak like all the time.
Well, I disagree, but so my name is Julia Mota and my pronouns are also she, her. I was a teacher and a tutor for elementary students in the Dominican Republic, and I've been supporting teachers and districts with their NGSS implementation for the past 3 years. I am an InnerOrbit's district engagement manager for the East Coast, so I work with partners to provide guidance to schools and districts implementing assessments in their NGSS instruction. And I think matcha is better than coffee. I would take it forever and never have coffee again. Now on to our agenda for today. So we're going to analyze, and during these 45 minutes, we expect to be here for 45 minutes, and we're going to analyze the release test items and dive into resources and strategies to build scaffolded practice for the New York Elementary, Intermediate Science Test, and the Regents to uncover actionable three-dimensional data. And we're going to start by comparing the 2023 and 2024 Regents item examples, and we're going to analyze the difference between those things. We're also going to talk about the three-dimensional shifts, and we're going to do that with some middle school questions too. And then we're going to talk a little bit about practice and sense making by using phenomena throughout a union, by scaffolding back a grade level, and then how we scaffold up with different types of questions. And the first thing that Emily's going to do is actually going to introduce us to InnerOrbit. And this is just going to take 1 minute, but we want you to know what we do.
Thank you, Julia. Yeah, I just want to introduce what InnerOrbit is and what we do before we dive in, just like Julia said. So InnerOrbit is kind of comprised of 4 things. The first of which is phenomena. So we have over 1,000 novel phenomena on our website that all of our assessments are tied to give students an opportunity to try to make sense of something new. The other thing that we are is questions. So with that 1,000 novel phenomena, we have over 10,000 assessment items that range from grades 3 through 12. And our assessment items are scaffolded in a way where students have opportunities answering one-dimensional content-only questions, and then two-dimensional, and then eventually three-dimensional sense-making questions, which are the types of questions that students are going to be seeing on like the New York State test. And we'll look at some examples of those here today as well. Another thing that InnerOrbit is data. We collect a bunch of awesome data from students taking their assessments, and our data can actually be broken down into the individual dimensions of the NGSS. So not only can you see how students are doing on content, on information, but you can see how are students doing on developing and using models. How are students doing on the specific parameters of developing and using models? Can they answer questions at a 3 and 5th grade level, but can they answer them at a 6th and 8th grade level? So this data gives you a lot of information to kind of help guide your instruction further. And the last thing that InnerOrbit is professional learning. So we offer a lot of professional development opportunities for those who are interested in InnerOrbit and our current partners to help leverage InnerOrbit, but also just to leverage the NGSS in general. So our professional learning is research and context-based. We do a lot of modeling of engaging classroom strategies, and we are constantly looking at teacher feedback and constantly revising and relooking at our program as well. So now that you know a little bit about us, let's start talking about what sense making is. You might have heard me mention that word a little bit ahead of time. And the reason that we're going to start off this New York State Science Test webinar with sense making is we're kind of seeing this shift for state science tests reflecting sense making questions. So what I'm going to show you here is an example of a question from the Regions 2023 Living Environment Test. And then I'm going to show you an example of a question that was released from the 2024 Biology Test. So what I would love for you all to do is, could you in the chat just note some differences that you notice between these two questions? And more specifically, what are the differences in what students are being asked to do?
Students are asked to answer cluster questions in the actual test that we've seen and with the release test items. So yes, they have to make sense, let's say, of something novel, of a specific phenomena that is clustered with different questions in our new release test item. So Sean is also sharing that students need to cite specific evidence from a question to support their answer rather than just recall information. And this is key because it's giving us exactly what the difference is more than just recall. And I love that.
And really that kind of highlights this idea of sense making. So if you're still typing a thought, please share, we would love to see it. But that main difference that we were seeing between those two questions is, one was essentially having students pick a best answer based on information they were already taught. And the next one, students had to cite evidence from multiple sources with a specific scenario they did not necessarily see before. And this is the shift that we're trying to make from representation to sense making. So representation is students communicating ideas that they've already learned. Essentially, like, my teacher told me this, bop, I'm going to go ahead and relay the information that I've memorized and that I've learned. This is an important part of learning. So students need to be able to know content and know information. This is good for diagnostic and formative assessments. It's important for development, but the key is it's not sufficient for proficiency. So just stopping at representation is not telling the full story, and it's not letting us know what our students are actually capable of doing. Sense making, though, is where we take that additional step to see if students can actually make sense of something new, to actually think like a scientist, look at some new information, and actually apply what they have learned in that new situation. So this is where this idea of novel phenomena comes into play. So something students have not yet experienced, and can they use what they've learned to make sense of it? This is perfect for a summative assessment because students need to compile everything that they've learned together in order to make sense of this new phenomena or this new problem that they're being presented with. And this is really the heart and the goal of the NGSS. So being able to use all three dimensions within a performance expectation and use all those components to make sense of something new lets us know that students have actually mastered the NGSS and the skills aligned with it. And that's really what the New York State Science Test is now modeling itself afterwards. So up here we have a performance expectation, HSLS21. And this is from the NGSS, and all these performance expectations have three dimensions to them. The DCI, disciplinary core ideas, science and engineering practices, sometimes referred to as the SEP, and the cross-cutting concepts, sometimes referred to as the CCCs. So the disciplinary core ideas is just like the content, the information that we've been disseminating to students. And just stopping at the DCI is like what representation would be. From there, though, we want to expand, and can they use the content in other ways? So the science and engineering practice is that skill of being able to use mathematics and computational thinking. So can they take the content and also use mathematics and thinking behind it? And can they also use the content with the scope of scale, proportion, and quantity? So combining all three of these dimensions together in the presence of a new phenomena is what we're aiming for with sense making, and is what the New York State Science Test is now aiming for in their questions as well. So with that, I'm going to pass it over to Julia, and she's going to give you some more examples of this sense making shift and how it specifically ties to the New York State Science Test.
And we've given our bio teachers some love. Now let's go into a specific middle school standard. And everything, just as a disclaimer, everything that we talk about here if it's a high school, if it's a middle school standard, it all applies to all grade levels and all content areas. So we're going to explore an example assessment items to make sense of the sense-making paradigm shift, to help us also understand how to prepare students for that end goal that is sense-making. And now diving into a middle school standard specifically. So this is MS-LS41, and students who demonstrate proficiency can analyze and interpret data for patterns in the fossil record that document the existence, diversity, extinction, and change of life forms throughout the history of life on Earth, under the assumption that natural laws operate today as in the past. We have the DCI, which is evidence of common ancestry. We have the science and engineering practice that is analyzing and interpreting data, and we have the cross-cutting concept that is patterns. Now, I read this out loud because now we're going to see specifically what the PLDs look like. And thinking about the NGSS, thinking about the NIST list specifically, New York's PLDs, or performance level descriptors, are guidelines. Just so you know, if you don't know what they are guidelines used by the folks designing the New York Science Test, and they're incredibly helpful for understanding what proficiency actually looks like. So at the elementary and intermediate levels, we're focusing on getting students to level 3, which is this one that I'm setting up right here. And that's the bar for proficiency. This is where students demonstrate the ability to make sense of a phenomenon in a way that aligns with the expectations of the standard. Now, at the high school level, just to make that clarification, there are 5 levels instead of 3. And level 4 becomes the mark of proficiency. So whether we're talking about elementary, intermediate, or high school, the key takeaway is that proficiency is all about sense making, and either level 3 or level 4 describes what it looks like when students can go beyond representation and apply their understanding to explain novel phenomena. So this is what we're aiming for, and these are the level 2 and level 1s. What I want to highlight here is that at the level 3, the PLD is actually the same as the performance expectation, and that's the target for proficiency. As you can see here, it's exactly the same wording that it's used in the PE. So this means that if we're designing instruction or assessment, our goal should always be to help students reach the actual performance expectation. And as we think about preparing our students, using the PLDs to understand the proficiency and the level that they're at is helpful, but remembering that getting to that level 3 means mastering the full performance expectation through the lens of sense making, and for students to be making sense of novel phenomena. Now, let's say we're observing 4 different teachers in a classroom, or 4 different teacher classrooms who are teaching the standards we just reviewed. So in those classrooms, all teachers are teaching the same lesson, but have different assessments they've created. In all the teacher lessons, they use this image to teach students about the law of superposition and the fact that fossil records help us understand the different things of lived there in places at different times. And now I'm going to show you. So I'm going to ask you, which assessment is closest to proficiency or sense making? So we have this lesson on diversity of the fossil record and the image we just saw. Now I have the 4 different teachers are asking 4 different questions. And I'm going to launch a poll, and I'm going to give you a second to read this so that you choose which one of the 4 teachers is actually meeting the performance expectation. Which assessment you think is closest to proficiency? But number 1, number 2, number 3, or number 4? I'm glad to see that we're all agreeing that it is number 3. Actually, the assessment on number 3. So all these teachers ask students to do rigorous things, but only the teacher number 3 asked them to make sense of something novel. And this is the critical part of new assessments and of these science standards. So right here, we highlighted where the analyzing and interpreting data, where the DCI is, and where the cross-cutting concept is. So all of the other tasks weren't necessarily sense-making, and we're not as rigorous as we're going to see on that test. So again, novel phenomena is crucial, and students will also see new phenomena in New York State tests that have not been covered in instruction. So they have to be able to make sense of these things. And thank you everyone for participating in our poll. And you were all right. Assessment number 3 was the one that was closest to proficiency and sense making. Now, let's talk about how we practice that actual sense making and how we would use phenomena throughout a whole unit. In thinking about the same standard, MS-LS41, we see the DCI, the SCP, and the cross-cutting concept. We've already talked about these things. Now let's say, and I'm going to build a roadmap of how we can use different phenomena throughout a unit to help give students multiple ways to practice making sense of novel phenomena for this specific standard. So let's say at the beginning of the unit, we can have a whole class discussion on how can this shell be older than dinosaurs, which look like ammonites. The shells, these are shells that are older than dinosaurs. So we could start with that specific phenomena for a whole class discussion and a whole class walkthrough. Then in the middle of the unit, maybe I could dip into what can this tiny horse tell us, where we look at the evolution of horse fossils over millions of years. And this phenomena can be printed out and given to students in groups to answer rigorous questions and work together to apply their learning into this novel phenomena. And lastly, at the end of the unit, we can give each student an individual assessment to actually assess sense making on gorgonopsid teeth. And these only talks about how interesting these teeth are because they represent a shift that are more similar to mammals, which are rounded rather than sharp like carnivore teeth. So something I want to highlight is that all of this phenomena you can find on InnerOrbit. And we have even more phenomena for this standard that we could use for additional review and sense-making practice. So we use 3 for our roadmap through to sense-making, but we actually have 7 different phenomena just for this lesson on InnerOrbit. So feel free to look at it and check it out. Now, let's say students are struggling to access sense-making for the middle school standards. We always have the option of going back a grade level, and then we could here go back to an elementary standard that precedes it. So even though we're in middle school, we could go back to 3rd grade, which is the alliteration for this specific MSLS standard. And as you can see, it assesses the same DCI, the same science and engineering practice, and the same cross-cutting concept just at the prior grade level. Now, again, these are additional phenomena we would use throughout this unit, and all these are in the InnerOrbit website. So we would first maybe discuss how can extinct giants tell us about ancient Earth. And this is just asking students about the giant rhino that lived 26 million years ago, and they were so big that they could eat leaves off of trees 50 feet above ground. Then we could go over the reason why you could find whales in the desert. And it's all about the fact that fossils are found where they used to live. And it shows us how the environment has changed. As we know, there are no whales in the desert right now, but there once were. And then, as you can see, all of this is found on the InnerOrbit website. So I also want to highlight that. Now, this all applies if we're at middle school level, we could go back to elementary. If we're at the high school level, we could go back to middle school. If we're at the elementary, we could go to the K2 level. So you can always apply this to the prior grade level. Now, talking about specifically assessing sense making with InnerOrbit's scaffolded questions, I would love to show you how InnerOrbit actually scaffolds questions to build up to sense making. Now we know that with the DCI only and the 3-dimensional standards, we have representation and we also have sense making. But how can we really bridge that gap? So on the left here, we have representation where students are working with just the DCIs. This is where recalling and communicating ideas that they've already learned is an important step of learning, but it doesn't give us enough evidence that students truly understand the science. They're just telling us what they know. Now on the right here, sense making is where students want to be, or where we want students to get to. This full 3-dimensional learning where they're explaining why or how a novel phenomenon happens using not only the DCIs, but also the SCPs and the cross-cutting concept. And this is what real scientific thinking looks like. But we can expect students to jump straight from one place to the other. So we use these 2-dimensional questions to actually bridge that gap and to act as a bridge between simple recall and full sense making. So some 2-dimensional questions combine the DCI and the cross-cutting concept, asking students to explain the how or why scientific knowledge applies through a specific lens. And others combine the DCI and the SCP, shifting students from recall and application by having them actually engage in scientific practices instead of just memorizing facts. So by incorporating these 2-dimensional questions on InnerOrbit, we're helping students build the skills that they need to fully engage in sense making with like a stepping stone that makes the shift to mastery feel much more achievable and less drastic. Now, Going back to our first standard that we saw, our bio standard, just to recap, it is asking students to use mathematics and computational thinking to support explanations of factors that affect carrying capacity of ecosystems at different scales. And now let's look at different types of questions that we could give students to practice and scaffold for these rigorous assessment items. And for that, I'm going to show you this example. Let's dive into this phenomena about earthworms. And this is all about a study to understand how earthworms affect microscopic organisms in forest soil. So they measured nitrogen and carbon, as you can see in these two graphs right here, to estimate their population. And now the first type of question, this is a question that only assesses the DCI. And this is what we call a representation question. And this type of question is really valuable. We are not saying that these are bad questions, but what it helps us is to see if students have the necessary knowledge before we ask them to apply it in a new context. In this case, it tells us if they are able to grasp the basic science behind the relationships between earthworms, soil nutrients, and microbial life. And if students can answer this correctly, it is a good sign that they're ready to move forward to start making connections, analyzing data, and explaining why or how this phenomenon is happening. So in other words, we can start pushing them towards sense making. And as you can see, this is just aiming at these standards HSLS11 and HSLS12. Now, taking a step further, our next question moves beyond just the DCI, and it brings the cross-cutting concept as well. So in this case, we're not just checking if students know the relationship between earthworms, soils, and microbial life, but we're actually asking them to think about scale, proportion, and quantity, and how these changes at a small scale can have a larger impact on the carrying capacity of organisms in the environment. And this type of 2D questions help students start making connections between different scientific ideas. At this point, they're not only just recalling, but they're analyzing relationships and applying their understanding in a little bit more meaningful way. It is an important step towards sense making, again, because it pushes students to explain why these interactions matter in the ecosystem. So we're still helping students. This is just a part of the bridge in the gap to build up to those three-dimensional sense-making questions that they'll encounter on those high-stakes tests and obviously in real-world science. Now pushing a little bit further into sense-making by bringing in a science and engineering practice. So now students are being asked to engage in the practice of science. In this case, they're using mathematical representation to analyze the relationships between earthworms and microbial populations. So this is a key shift because instead of just describing what happens, students need to use the data to model and quantify how these organisms interact. So this goes a little bit further because it requires application, critical thinking, and reasoning, which are all essential components of sense making, but still they're missing a little piece. So by combining the DCI and the SEB, this question is moving students even closer to full 3D learning and 3D performance, where they're thinking and acting like scientists. And now finally, moving on to our sense-making question. This is a look at a true three-dimensional question, and this is one that brings together all three dimensions, the DCI, the cross-cutting concept, and the SEB. So students have to apply their knowledge of the concept by using a cross-cutting concept and engaging in a science and engineering practice. So unlike a basic recall questions, students aren't just picking a fact here. They have to make sense of relationships between organisms, ecosystems, and data patterns, and analyze, apply the reasoning rather than just memorize the information. And at the end of the day, that's the end goal of the NGSS. We want students to be able to answer these questions independently, and we want to assess them to understand if they truly can make sense of scientific phenomena and transfer what they learned into these novel scenarios. And as we talk about the regions and the intermediate assessment and the fifth grade assessment, if we look at a three-dimensional, I cannot go through without actually showing you a three-dimensional open-ended question, because these type of questions is where we can really see how well students can put everything together in their own words. And this type of question is super relevant because when we're looking to prepare students for any of those New York tests, we're expecting a 60-40 split between multiple choice and constructed response and open-ended questions. So these are a key part of our practice, and we really need to include these just to make sure students can put those thoughts together and use their own words to make sense of something novel. Now, how can we check for sense making? So making sure we bridge that gap, and just to recap what everything that we've said, we would start with prior knowledge questions. We could start with prior knowledge question. Then we would just make sure for a core content question that students can answer questions about just the content, then that they can apply the cross-cutting concept, that they can apply the science and engineering practices to finally be able to answer these three-dimensional sense-making questions that they will have to answer on those tests that are coming up. And on InnerOrbit, I would love to show you how one of our reports look like. So this is some sample data that you can gather to help make informed instructional decisions to support students after giving assessments on InnerOrbit. So this is actual data for one of our partner districts, and they were giving assessments throughout the school year, and they were able to gather baseline data. And a little bit of this is somewhat predictive for other states, because for New York, there have been changes in the test, so we cannot say it's predictive for New York yet, but our team has actually been working with other state tests just to make sure that proficiency here actually reflects what the performance of the students have been in past assessments. So again, this is just one of our reports, and this data you could use, and as Emily says, we're very fond of data, so you could use to help make informed instructional decisions and have informed PLC conversations within your science departments. And I know that has been a lot in over 35 minutes, but I'm going to kick it over to Emily to wrap us up, to recap what we've talked about, and yeah, just to put the bow in the webinar.
Tie it up all nice and neat, this beautiful webinar present we've presented to all of you. All right, so Julia did a wonderful job walking us through looking at some New York State item and how we can kind of scaffold our students to get there. So we talked about how there's been this shift from representation to sense making, how this shift to sense making is three-dimensional within the NGSS, and then how we can get students ready to be able to answer those questions. So how we can incorporate novel phenomena throughout a unit so students are being exposed to that sense-making practice, and then how we can use different types of questions in order to get them to that three-dimensional sense-making goal that they're going to see on the test. Again, thank you so much for attending the webinar today. In the chat, Julia's going to drop the link again. If you would like to make a meeting with Julia in order to discuss potentially piloting InnerOrbit in your schools. Thank you again for hanging out, and have a beautiful rest of your day.